Okay, so now that we've done looking at a graph or looking at an equation and graphing it, now we're going to write the equation given the graph. And so we use the same form of y equals mx plus b, that kind of formula that all linear equations are related to. And the slope is going to be represented by the m, the y-intercept is going to be represented by the b. We saw that previously when we were writing the equation. And so, but here it is just kind of laid out for you that slope is m, y-intercept is b. And if the slope's not given to you, you've got to calculate it and then write your equation. Horizontal lines. This is kind of related back to what I was showing you yesterday or in the other videos about y equals and x equals as far as horizontal and vertical lines. Horizontal have slope of 0. So that means when you write it as a coefficient with x, the product's 0 because 0 times anything is going to be 0. And so the equation's written y equals whatever the y-intercept is. Y equals a number. For vertical lines, it's the lines have undefined slopes, and that means that they have a slope that can't mathematically be calculated. And the line's not going to intersect the y-axis at one point. It will either not intersect at all, or it will intersect at every point because it's on the y-axis. So the equations are written x equals, and it's the only time you're ever really going to deal with the x-intercept. So we are asked to write the equations for these 4 graphs. Let's take a look at the first one. The first thing that we can note is that we have a y-intercept right there. Okay, so when we look at that, our brains need to say, hey, that's going to be a point of, the y-intercept is going to be 1. So when we write the equation, it's y equals something x, and we're at positive 1. Now to figure out what the something is, we have to find a second point on the graph. So we go along the lines. On either way, we can move left or we can move right, and we find that we have a second point down here. Now, just upon looking at this, hopefully you're able to look at it and see, hey, this is going to be a negative slope because it's slanting downward or looking left to right, so negative slope. Now all we have to do is count how far down and how far over. What's our rise, what's our run, or how far up, how far over. We find that we are going down 1, 2, 3, 4, 5. We went down 5, so the numerator is negative 5. Over, how far over are we going? 1, 2, 3. So we end up with an equation of y equals negative 5 over 3. Sorry, that's not totally written clearly. X plus 1. Y equals negative 5/3 x plus 1. Remember that slope is comparing rise over run, so it can't be a mixed number, it can't be a decimal. So we could not write this as y equals negative 1 2/3 x plus 1. That's mathematically wrong. Even though your brain's telling you it's an equivalent mixed number to that fraction, to that improper fraction, slope cannot be a mixed number. It has got to be a fraction. Proper or improper, it must be a fraction. All right, now let's take a look at the second example. First thing we want to do is identify where is it crossing the y-axis. When I look at it, we see that it's crossing the y-axis at negative 2. We know that it's negative because it's below the x-axis. So when we write our equation, we know it's going to be y equals something x and we know it's going to be minus 2 because it's at negative 2. Now we find our second point. Now the beauty of this is we could technically find any point. We could use any of these that I'm circling because the line crosses exactly where we're exactly on the coordinates, but we're going to just simply use the first one to the right. So when we're calculating the slope, we're saying how far up or down do we go? We can look at this and say, hey, I know it's going to be positive because it's slanting upwards, moving left to right, slanting upwards, so I know it's positive. And I go up 1. Since I went up 1, my numerator's 1. And then how far over do we go? 1, 2. We moved over 2. Therefore, our denominator is 2. So the equation of this line is y equals 1/2 x minus 2 because the y-intercept was negative 2 and our slope was 1 over 2. We rose 1 and went down 2. If you're wanting to know about the points to the left of the y-intercept, ask in class, and they can explain a little bit easier those points to the left. All right, looking at this next one, we should note that we have no y-intercept. And since it's a vertical line, we know that our slope is undefined. No y-intercept, slope is undefined. This is our one example where we will have x equals for our equation. So now all we have to do is come over and see where do we cross the y-axis, the x-axis. We cross it at 1, 2, 3. Therefore, our equation is x equals 3. Now coming over to the last one. First thing we note is where do we cross the x-axis? Cross the x-axis right there, and that's going to be, where do we cross the y-axis? That's where we cross the y-axis, and therefore we cross the y-axis at -1. So now we have to figure out our slope. Well, there's a couple of ways to think about this. One, to logically think about this, we can say that to get from one point to the next, I move up 0 and over 1. And I know that it's going to be -1 for the y-intercept because we cross at -1. But the other way to think about this is to say, I know that 0 over 1 is 0. So I could write it like that. Or the way that you will see most math teachers write it is simply just y equals -1. And by writing that, that's going to indicate to us, I know my slope is 0, I know it's a horizontal line, therefore I'm just saying that y will be -1 no matter what value for x we plug in. It will always be -1.